All right, so we are solving equations with variables on both sides. So problem number 1. So we're going to follow the same steps as we did yesterday. First, we combine like terms if we can. They have to be on the same side of the equal sign in order for you to combine like terms. And then we go to order of operations, but working backwards. So in this case, I have 24 minus 3m equals 5m. So I have no like terms on the same side. So I can't do anything there first. But what I need to do is try to get my m's together. So generally, I will move the m that isn't by itself. So in this case, this 3m is over here with 24. So I would choose to move that over and join the 5m. So I would do the inverse operation and add 3m to both sides. So then I would drop down the 24 equals 8m. And then now it's a one-step equation, and I divide by 8. So I get 3 equals m. Okay, number 2 looks a little bit different because number 2 has 4 terms, and you have 2 terms on each side of the equal sign. So what you need to look at is your goal is to try to get your variable on one side and then your constants or just your numbers on the right side. So I usually start by moving my x variable. You could really start this equation 4 ways, and we should all end up in the same answer, no matter how we start. But I like to move my smallest x. That's what I choose to move first. So my smallest x in this case would be negative 8x, because it's smaller than 4x. So I'm going to choose to add 8x over to the other side. So on the left-hand side, I have 7 equals, and on the right, 12x minus 17. You could start a different way, and then at the end, we should all be at the same spot. But so now I'm going to keep x there, and I'm going to isolate it. So I'm going to add 17 to both sides. So 24 equals 12x, and then divide by 12. So 2 equals x. Okay, I want you guys to try number 3. Okay, I would choose to start by subtracting c. So 20 equals 3c minus 7, and then I would add 7. 27 equals 3c. Divide by 3. So 9 equals c. So no matter how you started, you should still get 9, hopefully. Okay, number 4. So a little more complicated. We have variables on both sides of the equal sign, and we have some parentheses there that we have to distribute before we can start. So that's what I have to start with, is doing distributive property on the right. So on the left, I'm just going to carry that down. Nothing's going to change on the left yet. And then I need to distribute that 2. So it would become 6z minus 8. Okay, so now it looks like what we just got done doing. So I would choose to move my smallest z, which is the 5z. So I would subtract that from both sides. And then be careful on the left-hand side, that 2 is actually negative. So you have to carry that sign down. And then I have z minus 8 on the right. Okay, and then my next step would be what? Add 8, yep. So 6 would equal Z. Okay, I want you guys to try number 5. Okay, so for number 5, I distribute. What'd you get when you did distributive property? 5a minus 15. So then I would choose to add 4a. And I would carry down the 3 equals, and then 9a minus 15. Then I'm adding 15. So 18 equals 9a. And then I need to divide by 9. So 2 equals a. Okay. Number 6. So again, I have parentheses, which means I'm going to have to do distributive property. So on the right-hand side, I need to distribute the 3, and I would have 3x plus 12. Okay, and then what should I do next? This looks different. Why? What's going on here? They're what? They're the same on both sides, right? The 3x's are the same. We haven't had that yet. So if I were to subtract 3x, what is 3x minus 3x? 0. It's going to cancel, and I'm going to be left with 0 equals 12. Okay, does 0 equal 12? Is that true? No. So if you're left with a solution that is not true, it could be any number equals another number, like 5 equals 20, 2 equals 35. It doesn't matter. If it's not true, then your answer is no solution. So this is your actual answer right here. No solution. Okay, not any other form of that. You actually need to write out no solution. So whenever you have some random number equals another random number and they're not the same thing, your answer is no solution. Okay? All right, another example is something, I'm going to add another example in here. So number 7. If I have this starting out, so again, I need to distribute. Okay, and then what would you do first? So if we subtract 2x, anybody notice what's going on here?
Wait, it's the same.
It's the same on both sides, right? It was the same on both sides right after we distributed. They were both 2x plus 10. Whenever that happens, if it's exactly the same on both sides of the equal sign, this is called identity. You'll hear it referred to as identity. You'll also hear it referred to as all real numbers, and this is the symbol for it. It looks like an R with an extra line. So you could actually write this or identity on your homework, and they would both be correct. So you'll hear that depends on the teacher, depends on the class or the textbook or the test that you're taking or whatever. You'll either hear it referred to as all real numbers or identity, either one. Okay? All All right, so for your homework today, you have a worksheet over 3.4.